Throughout the late 60s and the early 70s, musicians had access to a wide variety of effects pedals. Fuzz, compression, wah, phasing, all of these were available in the now familiar stompbox format. However, delay proved to be more stubborn. Sure, there were units that used magnetic tape or oil can designs, but the parts used to make these units were bulky and difficult to fit into a pedal enclosure. Luckily, there was an alternative in bucket Brigade devices. Electrical engineer F. Sangster, in association with Dr. K. Tier at the Philips Research Lab, set out to develop an integrated circuit that could delay an electric signal without the bulk and costly maintenance typical of designs that use magnetic tape. Their work, which spanned the mid to late 1960s, resulted in the development of the bucket Brigade device. When working in tandem with a good clock source, a single 4096 stage bucket Brigade device was capable of up to 205 milliseconds of delay. Rather impressive considering these chips were compact enough to fit into a standard dual inline package. By the mid-1970s, pedal manufacturers started to add bucket Brigade devices to their designs. Electro-Harmonix had their Memory Man, MXR had their M118, and when we entered the 1980s, Boss threw their hat into the ring with the DM2. The DM2 is one of the more sought-after analog delay pedals today, and to help us demonstrate how bucket Brigade devices work, we'll be looking at a prototype circuit based on the DM2 schematic. At the heart of this circuit is a bucket Brigade chip and its accompanying clock source generator. These two chips achieve delay by sampling the audio signal and passing it through a series of capacitors. Each of these capacitors is separated by a switch that is toggled on and off by a pair of clock signals generated by the clock source generator. As the switches alternate on and off, each sample is passed from one capacitor to the next until it reaches the end of the chain. So the length of the delay is dependent on the number of stages in the bucket Brigade device and the frequency of the clock signal as dictated by the equation time delay equals n number of stages over 2 times the clock frequency. Add in a couple of potentiometers which control the repeat volume and feedback, and you have yourself a rather versatile delay unit. You may have noticed that the delay repeats are quite a bit darker than the input signal. This isn't a bad thing. In fact, this is kind of how sound works acoustically. Higher frequencies lose more energy with distance than lower frequencies do. And from a mixing standpoint, this helps keep the repeats spectrally distinct from the input signal. Bucket Brigade devices aren't perfect. They need a lot of supporting circuitry in order to help mitigate some of the artifacts that they can add to an audio signal. This supporting circuitry, which includes filters and compressors, contributes a large part to analog delay's idiosyncratic tone. The first of these circuits is the input buffer. The purpose of this section is to give the pedal a high input impedance, as a low input impedance would draw too much current from the previous circuit in the chain and cause it to behave unexpectedly. In this pedal, a common collector or source follower is used to ensure a high input impedance. Next is the pre-emphasis and de-emphasis filter. This is an active filter stage designed with the purpose of attenuating any high-frequency noise that the bucket Brigade device may incur on the delayed signal. It does this by boosting the high frequencies before the signal reaches the Bucket Brigade device, and then attenuating those same high frequencies after returning from the Bucket Brigade device. This way, only the noise is turned down, while the spectral content of the signal remains relatively the same. The signal also passes through a compander. Bucket Brigade devices don't have much headroom, and overly dynamic signals may cause unwanted distortion. The compander compresses the signal before the Bucket Brigade device's input and expands the signal at the Bucket Brigade device's output. This maintains dynamics while avoiding distortion. Finally, there are the anti-aliasing and reconstruction filters. Since the Bucket Brigade device is sampling audio, the signals that pass through the device are subject to artifacts due to aliasing and quantization. The anti-aliasing filter is placed before the Bucket Brigade device's input to ensure no signals larger than the Nyquist frequency enter. The reconstruction filter is placed at the Bucket Brigade device's output. Since the Bucket Brigade device takes samples at quantized intervals in time, the output ends up looking like a stair-stepped version of the input. The reconstruction filter smooths out this distortion, effectively reconstructing the original continuous waveform. Both the anti-aliasing and reconstruction filters use the Allen key topology. This topology suits the task particularly well, as multiple Allen key filters may be cascaded together to create higher order filters that have steeper slopes between passband and stopband. Bucket Brigade devices made analog delay pedals possible, but long discrete delays were not the only thing they were capable of. In the next episode, we'll explore how having short, modulated delays further expanded the Bucket Brigade device's tonal possibilities.